3.5, equation solving and modeling.
Yeah, there you go, because
So we're basically solving exponential and logarithmic equations now, aka solve for x. So number 2, we've got 32 times 1/4 raised to the x over 3 is equal to 2. So I need to get x by itself. So the first thing I need to do is divide by 32. So I've got 1/4 raised to the x over 3 is equal to 1 over 16. So now I have an exponent up here. There's nothing else I can do other than if I have an exponential and I need to solve, I have to use a log to do that. So we start up here, we come down, up, and over. And so I have log base 1/4 of 1/16 is equal to x over 3. And then I'm going to multiply by 3. So I have 3 times log base 1/4 of 1 over 16 equals x. And then at this point, we would have to type this into our calculator. Now, technically speaking, well, yeah. It'll just be easier if you type it into your calculator. Yeah. If you can see it with the properties, you may not need to plug it in, but on most of them, they're not, the properties themselves aren't necessarily going to work. They might, it just kind of depends. So if you can see it with the properties, it would be 3 times the log base, 3 times the log base 1/4 of 1 over 4 squared. This property then says that's equal to 2, so then it's 3 times 2. But
I think I'm just gonna put it in my calculator.
you can put these ones in your calculator, that's fine, because there's going to be some that you have no choice but to put them in your calculator to solve them. So this would end up being 6. And if you're ever not sure if you did it correctly, take that 6 or whatever value you get and plug it back in for x, and then see if the entire side over here looks like what the other side looks like. Number 6. 3 times 5 to the negative x over 4 is equal to 15. So divide by 3, so I have 5 to the negative x over 4 is equal to 5. Now, these two things here, it's 5 raised to this is equal to 5. Would you agree that this is raised to a 1?
Yes.
So if they have the same base, that means our exponents have to be the same as well. So I can just say negative x over 4 is equal to 1. Multiply by negative 4, x is equal to negative 4. Log base 4 of 1 minus x is equal to 1. So if I start out with a log, I need to use an exponential to solve it. So we start here, we loop around. So I have 4 to the 1 is equal to 1 minus x. Subtract the 1. So I get 3 equals negative x. Divide by the negative, negative 3 equals x. All right, so pretty much all of those ones, obviously we could do without a calculator. Now, like I said, I don't mind on that first one if you're using a calculator, because the ones we're getting ready to get into, you're going to have no choice but to use a calculator, because it's not things that you would just like naturally know. Like, they're not going to come out to be whole numbers. They're going to be a lot of decimals. So 12.98 to the x is equal to 1.6. So I have an exponential. It means I need a log to solve it. So we come down, we make the L. So we have log base 0.98 of 1.6 is equal to x. And then you'll use log base on your calculator and tell me what that's equal to.
Negative 23.2.
Give me another decimal place.
6.
Okay. Negative 23.26. $14.
It wasn't me.
I know it's not. Oh, I don't know what they said. I know it wasn't you. 80 times e to the 0.045x is equal to 240. So how would I have to go about solving this one?
First divide by 80.
Divide by 80, so e to the 0.045x is equal to
3.
3. Now what?
Gosh. Do a log.
Yep.
ln of 3.
Yep, so it would be log base e, which is ln of 3, or ln, and then of 3 is equal to 0.045x. And then we just need to divide by that. So in your calculator, do ln of 3. Now make sure you close that parentheses if you're going to do it all in one step. If you're going to do it in separate steps, then you don't have to really worry about it. But divided by 0.045. And what do we get?
24.41.
24.41. Is that what you said? Okay. All right, both of those were exponentials. They started as exponentials. Let's look at one that's a log. 18. 3 minus the log of x plus 2 is equal to 5.
First minus 3.
Yep. So I have negative log of x plus 2 equals 2.
Can be divided by negative 1.
Yep. The log of x plus 2 equals negative 2. Now, I have a log. I need an exponential to solve it. We start at the base. What base is this?
2. Negative 2.
No.
10.
10. We have 10. It's a common log. Raised to the negative 2 equals x plus 2.
What? Oh, okay.
And so then we're going to subtract 2. So 10 to the negative 2 minus 2 equals x. So what is that?
2.01. Nope, I lied. Negative 1.99. Thank you. That's what it is.
Did you add 2?
Possibly.
All right, solve the equation by the method of your choice. It says support your solution by a second method. We're not doing that. 26. The ln of x squared equals 4. So, I'm going to solve this. We start here at the base, loop around. So I have e to the 4th, ln is log base e, equals x squared. So now what's going to happen?
Take a square root from each side.
And what happens when I do that?
I don't know.
E squared equals x.
What happens when I take the square root of both sides?
I don't know.
What happens to my answers?
Plus
We get 2, plus or minus. So plus or minus e squared is equal to x. Now, the book's probably going to write this as 7 point whatever it is and negative 7 point whatever it is.
You don't actually know that,
Yes, I do. I just put it in my calculator. But
What is it?
It's
Brian.
like
2.79. 7.29. 2.79. Not 7. It's 2.79.
E squared has to be like 7 something. I know that.
Why he's like this.
7 point what?
It's 3.9.
Thanks.
My mom told me that I'm too smart for my own things sometimes.
So do you need us to change it to the 7.2?
I don't care. I was just letting you know that the book is gonna probably write it that way, but e's and numbers, I'm okay if you leave it there, like there. Okay.
Luffy.
Oh. The interlopers.
I read that in 8th grade.
Yeah, that was a good book.
That was a short story.
I like them over there under the light together, and they drink each other. Yeah.
That's as good as the giver.
36 log of x minus 1/2 log of x plus 4 equals 1. So we haven't had any yet that have had like multiple logs in them, and so we need to obviously do one of them. So there's kind of, well, mainly one way we can go about this, but essentially it's going to combine the stuff that we did yesterday and now with the stuff that we did today of solving them. So if I have a number out here, what do I do with it?
Add it to the right.
Yep. So we're going to put it back up here. Whoa. So that's going to give me log of x minus log of x plus 4 to the 1/2 equals 1. Now, what happens when I am subtracting two logs?
They're divided.
They're divided, so we get the log of x over x plus 4 to the 1/2 equals 1.
So it's not as, you don't put parentheses around the fraction?
I mean,
Like if we're typing it in our calculator?
oh, if you're putting it in your calculator, you would have to, yeah, because otherwise it's not going to know. However, you can't, your calculator's not going to do anything for you here because of the x's. So now I would use the e to attempt to solve this. So we'd have 10 to the 1, or just 10, is equal to x over x plus 4 to the 1/2.
We could do x plus 4 to the -2, can we?
Well, this is really just the square root of x plus 4.
Multiply by the conjugate.
There's not a conjugate. It's not two things being combined.
Multiply both sides by x plus 4.
Seeing how far they're taking this problem, because chose one that I don't have worked out, so we're gonna see how far they take it, because I'm not sure
Already?
if they're actually going all the way or if they're.
Behind everything school basically.
What is this? 3 point.
Stupid on the exam.
That's why I do good with schoolwork, so I don't have to do good.
Pizza for a
Okay.
I haven't changed my views.
All right, they are solving it all the way. So, any ideas on how I could go about doing this?
We can multiply both sides by the square root of x plus 4.
we could multiply just the right side by x plus 4. Like, change the, like, get rid of the bottom.
Oh yeah, square root of x plus 4.
Like multiply it by the square root of x plus 4 over the square root of x plus 4?
Yeah.
We can try it and see what happens. Because I don't have this one already worked out, I don't know which way is going to be the most efficient way, so we're just going to try and find out. There might be a faster way, there might not be. So then we've got x square root of x plus 4 over x plus 4.
What was supposed to do for the other side as well?
We just multiplied by 1, so it doesn't matter. If I was just multiplying by the square root of x plus 4, not over itself, then yes, I would have to do it to both sides. Which, honestly, I think that might be where we end up needing to go with it, but we'll see. I'm not sure.
Then we multiply both sides by x plus 4. I really want to multiply both sides by something.
Let's try it. I don't know. Sure.
Watch.
So we've got 10x plus 40 equals x times the square root of x plus 4.
Subtract 40.
Oh, that was a big jump for me.
Divide by x.
We
and
just
then
multiplied
square
by
both
this.
sides.
I just distributed that
Okay.
as I did that.
We can divide by x and then square both sides.
Is this what you do on tests?
I draw
Oh,
pictures on this.
we can move the 10x to the right, and that way we have all the x's on the top, and then we can factor the x out.
Wait,
I think that's going to be a little bit excessive, to be honest, because I still have an x in the radical, so it's not going to do a whole lot for me. Because I think we're just working in circles right now.
Are we gonna have a problem like this on our test?
If we find the correct method that would make it faster, then maybe. I think I want to backtrack to the blue and square both sides.
Hey, someone just looked at the door.
It's like everybody just looked that way and know what was happening.
That's honestly a really
I'm not going to erase what we just did. I'm just going to try something different. So I'm going to square both sides, so that would give me 100 is equal to x squared over x plus 4.
Wow. that
What?
looks
Can we multiply both sides by x plus 4?
Sounds like a good idea to me.
Hey, that's what I was doing. I'm getting it right.
So 100x plus 400 equals x squared.
Oh.
Now, I prefer for my x squared term to be positive, so I'm going to move everything to the right so that I have 0 equals x squared minus 100x minus 400. I hope so. We're going to find out, though. So I need factors of negative 400 that add up to negative 100.
202. Nope.
That was my first thought.
401.
It's okay, my brain went there also.
What are we trying to get? Factor it.
We needed to add up to 100. So let's just,
50 and
I know that this isn't this stuff in red. I'm gonna get rid of this because I know that this is not it. So we're just gonna,
If I were to plug this into the quadratic equation, would it go faster than this?
yes, there might not be factors. Well, I say it might go faster. It will if there's not factors that work. If not, I would actually complete the square.
Okay. I don't remember how to do that.
Oh man, I guess it doesn't. I should just do it.
Did a factor tree so I can see if there's factors that add up to 100.
I don't see it.
Wait, 25 and 4. Wait, they don't add up to
That's
100, never mind. They don't. It's 100.
We're gonna have
I might just complete the square.
I was gonna say, I think I'm just gonna complete the square. So I'm gonna essentially undo what I just did of putting this 400 over here and stick it back over here.
Oh, that makes sense because 100 is the square root.
So then I'm gonna add a box to both sides to complete the square. And the only reason I can complete the square is because there's a positive 1 in front of here. So then half the middle term squared, half of 100 is 50. So 50 squared is what's going in here. What is that? 2,500? Is that right?
Yeah, 2,500.
Need a bigger box. Okay. So then this side over here is x minus 50 squared equals 2,900. Yikes. Take the square root of both sides. I get plus or minus the square root of 2,900, which I know is going to be able to break down or is equal to x minus 50. I'm going to try to break this down. 2900 breaks into 29 and 100. 29 is prime, 100 is 10 and 10, 10 is 2 and 5. So I can take out a set of 2s and a set of 5s. So I'm taking out a 10. So I would get 50 plus or minus 10 root 29. And then you could actually,
I just want to leave that as the answer.
now let me go back and explain why we would need to actually continue this and plug this in our calculator and get a number. I cannot have a negative inside of a log. So I need to make sure that I don't have an extraneous solution.
Can't we just say it's undefined at this point?
No.
Okay, so you got 50 minus 10 times. How do I square everything?
So when I do the positive one, I get 103.85.
And the negative one doesn't work because it ends up with a negative numbers.
What did you get when you did it?
Negative 3.9.
So this one is going to be extraneous because if I plug that in here, that's going to cause a problem. It won't cause a problem in this one, but it will cause a problem in this one. So the only one that works is the positive one, which is 103.85.
On our test, will it ask us for an extraneous solution if we have to put it down?
Well, when it says to solve, you would need to just automatically know to look and check this to
Okay.
see. Now, if it was just that part, it wouldn't be extraneous, even though the x is negative, because it doesn't make what's inside negative.
It's plus 4.
It's extraneous because it's negative.
Not because the number is negative, well, kind of is, but because when I plug it in, it's negative in here. But that's what I was saying with this one, if I plugged in the negative 3 point whatever, it would still be positive in here. So it's not just that the number is negative, it's when I plug it in, I would have a negative in a log, which is a problem.
I'm really hoping we don't have that.
You probably will. 38. The log of x minus 2 plus the log of x plus 5 equals 2 times the log of 3.
So we can go ahead and do the multiply thing.
Yep, so log of a product is equal to the sum of the log, so we would multiply this stuff over here, so we would have the log of, if you want to go ahead and FOIL this into here, you can, just to save a step, so that would give me x squared minus 2x plus 5x, so plus 3x, and then minus 10 equals, what do I do with this?
Throw it out and
Log
square
3
it.
squared.
So log of 3 squared or log of 9. Now, what's true about both of these logs? But, well, obviously there's an equal
Oh.
sign between them.
The numbers inside are equal
Why?
because a log of A equals log of B, A equals B.
So if the base is this is 10 and this base is 10, that's what I'm trying to say. The bases are the same, so now the stuff inside has to be equal. So x squared plus 3x minus 10 equals 9. For the same reason that we had, where was it? It's a long time ago. Where the 5s on the exponents, if the bases are the same, the exponents have to be the same. So with the log, if the base is the same, the stuff inside of them has to be equal.
So we set it equal to 0.
So that's the first thing I would do is I would move this 9 over and get x squared plus 3x minus 19 equals 0. See if it's factorable. Are there factors of 19 that give you 3? No. So what I would do then is I would move the 19 over to the right and complete the square because, again, there's a 1 in front of here. So x squared plus 3x plus box equals 19 plus box. Half the middle term squared, well, that's 3 halves squared. Or 9 over 4 if we want to write it that way. So on this side, I have x plus 3 halves all squared equals over here, I need to rewrite this as something over, or like the 19 as something over 4. What would that be?
16,
76 over 85 over 4 total. Or 19 over 4 is 86 over 4, or 76 over 4.
Okay. So then add those two things together, we get 85 over 4. Take the square root of both sides. X plus 3/2 equals plus or minus. Now, I would go ahead and split this and do a radical on top, radical on the bottom. Why might I do that?
because 4 is squareable.
Yeah. So plus or minus the square root of 85 over 2. I went ahead and took the square root of the bottom. Subtract 3/2, x equals negative 3/2, plus or minus the square root of 85 over 2. Now, again, because I can't end up with a negative inside of my log, I need to check these values and see if they might both work. They might not. We just have to see.
The negative 1 does not work.
What did you get when you did the negative 1? I did the positive 1.
Negative 6.11.
So that means that if I plug in that negative 1, that's going to be a problem in both of them. But to check the positive 1, 3.11, I went too far. Minus 2, that's good. Plus 5, that's good. So the only one that actually works is 3.11. So you're going to need to be able to use the properties that we've gotten to solve equations at this point.
Do you care if we use the complete the square or just quadratic?
No, I don't care. I just think completing square is easier. All right. So these last couple of problems, not that you necessarily would need them on the AP exam, but I think it's good for you to have seen it. Cash, this will probably look a little bit familiar because it's order of magnitude, and we did that early in the year in physics. But they're order of magnitude problems, but they're a little bit different than what we did because of just the nature of the class. But they want you to determine by how many orders of magnitude the quantities differ. So with 42, not 22, 42, if I can write the correct number, it says lemon juice with a pH equal to 2.3 and root beer, aka I changed the problem, with pH equal to 4.1. Yeah. Question left off root.
Do you think if they had Bud Light back then, Jesus would have turned the water into Bud Light?
Probably not.
Why not?
I don't know. I think wine is probably classier for a wedding.
That's our what winning.
Okay, so on one like this, all I need to do is subtract the two numbers because they have the same like value. It's just like 2.3 and 4.1. They're not anything like crazy. So this one is literally just 4.1 minus 2.3,
I think we should have more problems just like that.
which is 1.8. So the order of magnitude of this one is 1.8.
What is an order of magnitude?
Powers of 10.
Yeah.
Which we'll be able to see better in the next one. This one will look a little bit more like what we did in physics class. So 44, the sound intensities of city traffic at 70 decibels, dB, that's what it means, decibels, and the rustling leaves at 10 decibels.
60.
So we would do 70 minus 10, which is 60, but that's how many decibels it is, but in order of magnitude, we're looking at powers of 10, so this would be 6 orders of magnitude. Now, in physics, just for everyone else, we essentially figured out approximately, I think it was how many gallons of gas are used per year in America using orders of magnitude by figuring out approximately how many cars each family would have. We figured out roughly how many people there are in the country. We figured out approximately how many people are in each family, roughly how many cars each family has, and then approximately how many gallons of gas. But obviously there's some crazy things there because you have electric cars, and then you have a Prius, and then you have, a Dodge Ram, and you have all these things that have but in theory everything should even out, and so we were able to figure out, I don't remember what the number was, but anyways, approximately how many gallons of gas are used per year in America.
Are you considering both diesel and regular?
We just were doing gas, so not really, but when I write down your homework problems.
I would use the restroom more. Well, I asked first.
Anyways, in case any of you take physics next year, as a little preview for you.
What is order of magnitude?
No.
Powers of 10. It's just a way to estimate things, basically. In physics, we use it to estimate. And here, we're just doing it as powers of 10. We're doing exponentials. All right, 1 through 17, every other odd, and then 25. I have to look at this. 20, not 29. Absolutely. Y'all would hate me if I gave you 29. 37 and 41.